Good morning. We had a few questions on quiz number one that I need to look over here. All right, so the first question right here, we'll call it number one. It says solve the radical equation, check all proposed solutions. Step one is you isolate the radical. So this is the radical, so isolating it, so it's all by itself on that side of the inequality, on that side of the equal sign, when you get rid of the plus 7, so minus 7. So then that ends up with radical x equals x minus 6. And then step two, square both sides. So radical x squared is x. And then x minus 6 squared is x squared minus 12x plus 36. Because you have to do x minus 6 times x minus 6. You have to FOIL it. X times x, x squared. X times minus 6, minus 6x, minus 6x. Minus 6 times minus 6 is plus 36. And then you add the middle terms and it's negative 12x. Then, because it's a quadratic, you have to move everything to one side. So I'm going to move the x over there, which makes it minus x. Whenever you move anything left or right, it changes the sign of it. And it's currently plus x. So on the other side, it's minus x. So then you got x squared minus 13x plus 36. And so to solve the quadratic, then you have three ways you could do it. The quadratic formula, negative b plus or minus radical b squared minus 4ac over 2a. Or you could factor it, or you could graph it. And if you graphed it, you want to see where it crosses the x-axis. That's where the roots are. I'm going to factor it. It factors into x minus 4 times x minus 9. Again, the factor, you need two numbers that multiply together to be positive 36, and then add up to negative 13, and negative 4 and negative 9 multiply to positive 36 and add up to negative 13. Then you set each one of those factors equal to 0, and you solve it. So you get 9 and 4. But see, they've only got the one answer of 9. Let's see what happens if we plug 4 in. So if we plug 4 into the original one here, square root of 4 plus 7, does that equal 4 plus 1? You get 2 plus 7, which is 9, and that does not equal 5. So, and then if we check the 9, put the 9 in for the x up here, you got the square root of 9 plus 7 equals 9 plus 1. So that gives you 3 plus 7, 10, which equals on the other side, 9 plus 1, 10. So that's why the only answer to it was 9. All right, let's move on down here. Look at the next problem. Says determine the constant that should be added to the binomial so that it becomes a perfect square trinomial. So what you want to do is the number in front of the letter x, we'll call that step one, number in front of x. And it's in front of the linear x, the x that's to the first power. There's no power there, so it's a 1, not the one in front of x squared, the one in front of x. Find that number, take half of it. Half of that number. So a third times a half is 1/6. Multiply straight across, or use your calculators. A third times a half is a 6, and that is the new number that you're going to add to it. 1/6 squared, which is, when you square it, 1 over 36. And then the perfect square trinomial down there. So rewrite it, it said. So rewrite this. So you just 1/6 squared, like we said, is 136. A 6 times a 6. Again, multiply across 1 over 36. Or again, you could use your calculators. 1/6 times 1/6 is 1 on a 36. And then I got to hit clear to show you the bottom of it here. I'm sorry. But then they wanted to know what is factor the result. And it's a minus here in the in front of the x squared, so that's why that's a minus down there. If this would have been a plus, that would have been a plus. Let me show you on a simpler one. If you had x squared minus, let me see, minus 4x plus 4, that factors into x minus 2 times x minus 2 because of the minus sign there. Let me do one with a plus sign on it. So if we had x squared plus 6x plus 9, that factors in x plus 3 times x plus 3 because that's a plus sign. And you could have solved this by completing the square like we just did. Half of 4 is 2, squared is 4. Half of 6 is 3, and when you square it, it gives you 9. All right, on the next one we got, they would like, ooh, right, let me go back. All right, I don't know if you saw what just happened, but all right. So it wants you to use those to find what set it is. I would graph it. So we have on a number line, on the left, it's negative infinity. On the right is infinity. I'll put 0 on there, -3, and then we have -7. Oh, and then we got this. Yeah, we got all the numbers. So the first one there we have is negative infinity to -3. So negative infinity is all the way over here, over to -3, and it's going to have an open circle on it because it's a parenthesis. If it's a parenthesis, I'm making such a mess. If it's a parenthesis, it's not included. And so that's designated with an open circle. It's not part of the answer set. And then the other one here, we have -7 with a bracket. So that means -7 is included. And it's going over to the number 0, but 0 is not included. So it's an open circle. And now this is a union. So that means everything there. So the solution is all of it. Well, this number is there. That's every number is represented from negative infinity to the number 0, but not including the number 0. So that's how come it's negative infinity to 0. That's the right answer, by the way. Negative infinity to 0 with a parenthesis, not a bracket though. It's a parenthesis because the end of it was a parenthesis. And then just as an aside here, if we're going to suppose land, if instead of a union, if that said an intersection, let me do it again. If it said intersection, so we have the first one there that was negative infinity to -3. And the other one was -7, colored in because it's a bracket, over to 0. Intersection is like a road. And where does the road intersect? Well, these two colors here, these two graphs or sets intersect from -7 over to the 3. They're both there. But notice at the 3, that's open. So it's not included on the bottom red set, but is included up above. So it's not in the intersection of it because it's not in both sets. So the intersection of it would have been a bracket, -7 to -3 with an open parenthesis because the -3 isn't in both sets. To be in the intersection, it has to be in both sets. And the -3 is not in both sets, but the -7 is in both sets because it was colored in here or included with a bracket. All right, moving down here. Okay, another set builder question. So they wanted to know what this was and from interval to set builder notation. And the person, when they got it wrong, made the mistake of what I was talking about. A bracket means that it's equal to or colored in. So it'd be a closed-in circle on the picture because it's included. The parenthesis, it's not equal to it. So it's an open circle. So a bracket has an equal to sign. A parenthesis, there's no equal to signs. Again, that is the correct answer down there. The person that missed it put, I think, anyway, they didn't put an equal sign, I think, on the one on the left. All right, and then down here, looking at the answer, it's from -4 to 4, which all of these choices have. But we need on the -4, closed circle, which this has, because it has a bracket on it. This one does not, and this one does not. It has a parenthesis on it. And then for the 4, it needs to have a parenthesis or an open circle on it, which this one does. And that one did. So that left A to be the answer to it. So again, one more time, if it's a bracket, it's colored in and it's equal to it. If it's a parenthesis, it's open and it's not equal to it. That's it. All right, my other question I got was about writing, simplifying radicals. So I made up some radicals here to simplify. The person didn't give me exactly what number she wanted to simplify, but if you wanted to, let's just start really easy. If you want to simplify radical 9 is 3 times 3. So the square root of 9 is 3. We all know the square root of 9 is 3, and that's because you've got a pair of 3's. Notice when you simplify, you got 2 and 1 comes out and the other one's just gone. The answer is just 3. So keeping it simple here again, the square root of 27, if you made a factor tree from it, so 9 times 3 and then 3 times 3, 27 is 3 times 3 times 3. All right, so we have a pair of 3's. This one is not in the pair. The one not in the pair has to stay underneath the radical and it's trapped. It's not going to get out. The one that has a pair of them, you take one out and the other one's gone. So you take out 1 3 and the other 3 is gone. All right, square root of negative 90. Again, we can make a factor tree. 90 is 9 times 10, 3 times 3, 2 times 5. So we have the negative sign, 2 3's, a 2, and a 5. We've got a pair of 3's, and we got the negative. When there's a negative under it, you take out the letter I for it. And then the pair of 3's, you have a 3 and 2 times 5, because those are trapped. You can't take them out. There's not a pair of them. So whatever is not in a pair, you multiply together. So it's 3i radical 10. All right, and then we'll make it a little bit harder. 5 square root of negative 80. Okay, for the 80, make another factor tree. Any two numbers you want multiplied together. I'm going to go with 2 times 40, and then that's 2 times 20, 4 times 5, or 2 times 2. So the end of the factor is what makes the number 40 is, number 80. The number 80 is composed of all these factors. 1, 2, 3, 4 2's, and a 5. Oh, and it was a negative. All right, so we have a pair of 2's, another pair of 2's, and then that 5. So let's leave the 5 behind. Take out a 2, take out another 2, and then we're going to take out the I. Oh, and then we had the 5 in front, so bring the 5 down. Okay, so we're bringing the 5 down. We brought the I out. We had 2 pairs of 2's, so we took one out for each pair. And everything that you brought out, you multiply together. So 5 times 2 times 2 is 20. So it's 20i radical 5. So I hope that helps a little bit. I think overall, maybe what you should be doing is making a factor tree if you're having troubles doing this, and figure out what all the numbers are that multiply to make that number together down to all their factors. All right, well, I hope that helps you guys. I'll talk to you later, and let me know if you want some other problems worked out. Thank you.